Okay, next section. Learning about rectangles. Yay. Okay, this is section 3. So similar to what I did with parallelograms, I went and filled in the blanks here. Properties of rectangles. So rectangles have the same initial 5 properties as parallelograms. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and then the diagonals bisect each other. And then it also adds 2 new properties that only apply to rectangles. And so that's that all 4 angles are right angles. So what that means is, like if I'm looking at this shape down here, that means that all 4 of these are right angles. Also, the diagonals are congruent. So when they bisect, when they bisect, they actually create all 4 congruent pieces. Well, okay, the diagonals in general. This is congruent to this. This is congruent to this here. Which means that all 4 of the bisecting pieces are also congruent. So I can go ahead and draw, I guess I can draw a rectangle up here so that we can see this. It's not a very good one, but it'll do. So my 2 new rules that apply are, that was a terrible diagonal. Not good enough. So my 2 new rules are saying these 4 angles are right angles, and that all of these are congruent because my diagonals are congruent. So let's use these and let's find the missing measures on these rectangles. So on number 1, we want to find QR. So since QR is opposite PS, that means QR is also 10. We want to find SR. Since SR is opposite PQ, then SR is also 24. Okay. Now, SQ, finding the diagonals is where we get a little tricky. But fret not a big deal. So notice how we know these 2 sides. And we know that this is a right angle because it's a rectangle. Okay. My diagonal cuts this rectangle into 2 triangles, essentially. Let me see if I can't white out this diagonal here so you can see kind of what I'm talking about. There, kind of white it out so you can see what I'm talking about. Okay, so when I cut this diagonal SQ, I form, because this is a right angle, I form a right triangle here. Okay, remember we have that cool thing that we learned last unit where if I have 2 sides of a right triangle, I can find the 3rd side. So I can find SQ by using my Pythagorean theorem, which remember is a squared, oh that's terrible squared, a squared plus b squared equals c squared. Okay, so I can take, see, SQ is my hypotenuse, so if I label that x, I can take 10 squared plus 24 squared, and that's going to give me SQ squared, or x squared. So I use my Pythagorean theorem. So 676 is x squared So when I take the square root of that, x ends up being 26. So SQ is 26. Okay, now let's see if I can erase all my stuff here. Okay, since SQ, right here, was 26, I want to find PR now. Now remember, because of this new property number 2 up here that I learned about rectangles, the diagonals are congruent. Since SQ is a diagonal and it's 26, that means PR, that's the other diagonal, is also 26 because they're congruent. Okay. Then the last one it wants me to find is QT. Okay. Now remember, since the diagonals bisect each other, that means this is congruent to this. ST is congruent to QT. So, since SQ, the whole thing, is 26, if I cut that in half, I'm going to find QT. So 26 divided by 2 is going to give me 13. Okay. So that's number 1. Let's skip number 2 and let's look at number 3. Now we're going to look at some angle things. Try not to butcher this one like I did on parallelograms. Man, that was bad. So, all right, I'm given angle KJL, which we know is congruent to angle KLJ. All right, 27 degrees in there. And then, okay, let's look and see what I'm trying to find. MJK. MJK. So I'm trying to find this angle right here. Well, that's pretty easy. Because it's a rectangle, all of these angles here are 90 degrees. So that means MJK is 90 degrees. Now I need to find MJL. So that means I want to find this one. MJL. Well, since we know MJK is 90 degrees, that this whole thing is 90 degrees, and I know that KJL is 27 degrees, to find the angle, the measure, I don't know if I can work, measure of angle MJL, that's what I'm trying to find, right? Yeah. MJL, I can take 90 minus 27, and that's going to tell me that angle. And so MJL is equal to 63. So MJL is 63 degrees. Okay, moving on. Now I need to find JLK. JLK. Okay. That's this one right here. Lucky for us, this one is an opposite interior angle of the one I just found. So that means that JLK is also 63 degrees. Okay. Then I need to find KML. Okay. And so this one's a little bit different. So, oh, now I remember what I did. Okay. So since all of these are congruent because it's a rectangle, notice this down here, or it forms a bunch of different triangles. So notice this triangle down here that it forms. Okay. Think back to our properties of triangles. So remember when I have two congruent sides of a triangle, these two angles are congruent. So that means that angle NML KML or KML is also 27 degrees because this makes an isosceles triangle. So because these two sides are congruent, these two angles are congruent. Okay, so that means that angle KML is 27 degrees as well. All right, last one I need to find is MNL. So I'm trying to find this one right here. Okay, well, we can use what we found out with KML to find the measure of angle M. Wow, it's not an M. MNL. So since I formed this triangle here, and I know 2 of the 3 angles, I can take 180, since all the angles of a triangle add up to 180, minus 27, and that's going to tell me the measure of angle MNL, which ends up being 126. And that's all of the angles it's asking for the rectangle. Okay. So, number 4 is a little bit tricky, but I want to see if you guys can do that on your own, as well as number 2. And then number 5 is putting those two together. So it's putting both types of problems, sides and angles, together. So it gives you the side D, or it gives you the length of DB, gives you the length of AD, and then the measure of angle DAE. So use that, use what we just did, and use your properties of rectangles and try and find those other sides and angles that it's asking. Okay, and then if you flip it over, this is very similar to the back of the first parallelogram sheet. You're using those properties of parallelograms that you used on 1 through 5, but now we're throwing some algebra in it. So, for instance, if I look at number 6, I want to find the measure of EF. In order to do that, I have to first find X. Since these CD and EF are opposite sides, that means they are congruent. So that means 7x minus 39 is equal to 3x plus 5. Okay, so that way you can solve for x, and then pay attention to what it's asking. It's not just asking for x, it's asking for the length of EF. So remember to plug that x back in and solve for the length of EF. Number 7, won't go over that one. I'll let you try and do 7, 8, and 9 on your own there. Real quickly, just want to look at number 10. Same thing, except with angles now. So notice how these two are opposite or alternate interior. Therefore, they are congruent. So 7x plus 5 equals 11x minus 3. So then solve for x. Then it wants the measure of the angle, so make sure that you think about what that angle is going to be. So, for instance, I want to find the measure of angle BCE. So it's wanting to find this angle measure. So think about what you can do there to find the measure of angle BCE using your properties of rectangles. So do the rest of those 7 through 13 as well as 2, 4, and 5 on the front. And then we will look at these on Monday.